Okay, so what Hubble discovered was that different galaxies have different Z parameters. By that we mean different galaxies, they're all receding from us, but different ones are receding at different velocities, some less, some more. And Hubble decided to try and figure out why is that. So he went to take another measurement and he tried to work out how far away are each of these galaxies from Earth. Now that's tricky to do, trickier than actually measuring how much the light's being redshifted. But how he did it was this. If you imagine standing, say, on our hockey pitch, okay, and you have a couple of friends who each turn the torch on their phones, what you would observe is the person who is closer to you, their light will appear brighter, and the further away someone is, the dimmer the light appears to you. Now, what we can do is, if we know the actual amount of light that each of those phones is producing, and we then detect how much of it gets to us, i.e. how bright or how dim is it, we can then do some maths to work out how far away each of those people would be. Now, this only really works if the phones are identical. So if you have an iPhone and someone has a Samsung, the brightness of those the lights on them will be different, and then that would cloud our ability to be able to work out how far away they are. So what Hubble needed was, he was going to do this with stars, and he needed stars that he knew the exact brightness that they would be in real life. So what he needed to look for was something called the standard candle, a star that he would be able to identify and say, okay, this is normally this brightness, so if it appears this bright to us, it must be a certain distance away. And he was able to find a particular type of star called the Cepheid variable that he could identify. And when he found this type of star, he would measure how bright it appeared from our observing location, and from that he would be able to work out how far away the galaxies were. And he took lots and lots of readings over years, and both of the distance the galaxy is away and also the amount of redshift, the Z parameter, or the recessional velocity, essentially. And what he was able to do then was draw a graph of his results. And what he found out was this. Okay, there's a little bit of difficulty in getting these measurements, so we wouldn't expect all our points to lie perfectly on a straight line. But once he got enough data, it was very, very clear that these two things were directly proportional. Okay, that we should get a straight line through the origin.